Hello everyone, welcome back to my channel Shah Sir Classes. I am Shah Sir here. My dear students, a warm welcome from Evershine Coaching Center for you all. Today in this class, I am going to discuss the chapter Metals and Non-Metals. So here in this session, we are going to cover the complete chapter in detail. Okay, so here we are going to cover each and every topic of your text of NCERT syllabus of class 10th, metals and non-metals. Whatever the contents is given in your textbook, the same contents we have elaborated in the simplest form through which you people can easily understand, and also the concept should be exam ready. Okay. So believe me, once if you watch this video, you can answer any kind of questions, any set of questions. And also please make a note of few important points, whichever you find as an important. Okay. Whichever you feel as an important, please make a note of it. And most important thing is wherever we see the tables, these tables are very important for you guys. Okay. Let's get started without wasting much time. Now, as you know about elements, okay, so these elements are classified as metals and non-metals on the basis of their properties. Now I'll give you one element, I'll give you another element. Now once I give you these two different elements, in this you want to identify which is a metal and which is non-metal. Simple question. I have given two elements, this is my element A and this is my element B. I have given two elements. Now we need to identify which is the metal and which is a non-metal. How you are going to find and how you are going to trace out which is metal and non-metal? It is just based on their properties. Understood? So this was very helpful when they are going to frame the periodic table. So many abundant elements they found, where they have to keep, which element where they have to keep, in which position they have to keep, which should come first, which should come next. Understood? These all things, there was a much confusion during the time. So this concept was helpful for them to frame the elements, to locate the elements in the periodic table. Understood? So anyhow, we are not going in deep about periodic table in this chapter. Here just we are going to discuss what is a metal and what is non-metal and also their properties, and how metals behave when they react with some other element, and how non-metals will behave when they react with some other elements. That is what we are going to study in this chapter. समझे बेटा? इस चैप्टर में मेटल्स और नॉन मेटल्स के बारे में पढ़ेंगे, उनके प्रॉपर्टीज के बारे में पढ़ेंगे और उनके बिहेवियर के बारे में पढ़ेंगे. How they are going to behave. And also, when you are going to combine both metals and non-metals, what they are going to become and how they are useful to us. That is also we are going to study in this chapter. That's it. Nothing much. And very important concept is how we can extract the metals. We are going to study in this chapter. Extraction process. Okay, what is extraction? All the stuff. Anyhow, I am going to explain you in the further chapter. So this is the basic introduction regarding the chapter metals and non-metals here. Anyhow, the metals can be classified and non-metals and elements are classified into metals and non-metals based on their properties. That you should not forget. Some elements, example of metals. Some elements such as metals, examples are iron, aluminium, silver, copper. These are the few examples of metals. Which are the few examples of metals? Iron, aluminium, silver and copper. Iron symbol is Fe. Aluminium we are going to use the symbol Al. Silver is Ag and copper is Cu. And some examples of non-metals are hydrogen, nitrogen, sulfur and oxygen. Hydrogen is H, capital H, not small letter h. And please remember these symbols where we have to use capital letters and where we have to use small letters. Okay, where we have to use capital letters and where we have to use small letters, that is small alphabets. Be careful to symbolize the elements. So some non-metals are hydrogen, nitrogen, sulfur and oxygen. These are all non-metals. Okay. Now we have understood few examples of metals and non-metals. Now first let me understand physical properties. My dear students, in exam they may ask you this question. in different ways. Please be careful when you are going to study this topic. They may ask you, write any four physical properties of metals. Sometimes write any four chemical properties of metals. See, physical properties and chemical properties, these both are not one and the same. These both are different. But in hurry, what we do, we see a word just properties. We don't see whether it is physical or chemical. Sir, I know answer. Properties of metals? Yes, sir, I know. Be careful and read the complete sentence before you are going to answer such type of questions. Now, here we are studying about physical properties. Now, I'll give a small example. So, what is the difference between physical properties and chemical properties? What's the difference between physical and chemical properties? See, children, very simple. Physical properties are nothing but those properties. Physical properties are nothing but those properties which we can see and feel, which we can see, which we can see and feel. That is physical properties. Chemical properties are those which we can't see but still we can feel. Those are the chemical properties. Simple. Physical and chemical. Physical properties are those properties which we can see and feel. Chemical properties are those properties which we can't see but still we can feel. We can say it is a metal, still we can say it is a non-metal. Those are called as chemical properties. Now, in this concept, we are going to study about physical properties. See, children, the first property is luster. Metals are lusters. Metals are hard in nature. Metals, their property, their state, how they are available in the nature. How metals are available in the nature, in which form they are available. Either they are available in a solid form or liquid form or gaseous form. That is nothing but we call it as a state of matter. Clear? And also we are going to study about malleability. That is another property of a metal. And another property of a metal is metals are ductile. Metals are malleable. Property name is malleability. And also we call them as malleable and ductile. That's nothing but ductility. And metals are good conductors of heat and electricity. And the density of metals. Why we call them as metals? It is also with respect to their density. If density increases, what happens? If density decreases, what happens? What they are going to become? If density increases, what they will become? If density decreases, what they will become? Clear? That is also one of the property. And metals are sonorous. Metals are sonorous and they form oxides. Metals they form oxides. Clear? Now let me study one by one in detail what exactly it is and how in the examination they will ask the question based on these properties. Based on these properties, very importantly, they will ask give reasons questions. Most number of give reasons questions in case if they wanted to ask in the examination, dear students of class 10, either they belongs to CBSE board or any Karnataka state board or any board who is following NCERT syllabus. Believe me, this is the chapter, lone chapter, which is having a very high chances of asking give reasons questions. Give reasons questions, the very high quantity, a very high quality of questions can be asked with respect to the chapter metals and non-metals. So each and every word you have to identify. And also, if you are going to get any hot questions, higher order thinking questions, or case study based questions also can be extracted from this chapter because such type of questions are available in this chapter. Done? Now let me study the properties. Now metals are lustrous. What do you mean by lustrous? Lustrous means shining. What do you mean by lustrous? Lustrous meaning is shining. They have a shining on the surface. On the surface of a metal, they have shining. That is called as lustrous. Shining. So metals have high shining surface. But similarly, compared to non-metals, they do not have shining surface except iodine. Except iodine. See, iodine is a non-metal, but still it has shining surface. So this is one kind of hidden question. Am I right? Iodine is a non-metal, but still It looks like metal. Still, it looks like metal because it has shining surface. Concept is clear? Understood? Yeah. Now they may ask you any give reason question even on this property. Some example they will give you and they will ask you which property of the metal suits this definition or statement. Which property of the metal suits this statement, they will ask you the question. Then you should tell which property? Lustrous property. Lustrous property is the property which signifies, which shows they have shining surface. And similarly, hardness. Already you know that. Already you know that metals are hard in nature. They are generally hard, but except sodium, lithium, and potassium. My dear students, actually, to speak, metals are hard in nature and non-metals are soft in nature. Generally, metals are hard and non-metals are soft. For an example, let me say I'm taking this duster. For example, this is hard, right? It's hard surface. Am I right? So it's not a metal, just I'm telling. As soon you hold this, you can tell that it's a metal because it is hard. Similarly, I will use one small paper, I will hold it. It is soft. As soon you hold it, you can tell that it is a non-metal. Am I right? If they are soft, non-metal. If they are hard, it is metal. But some metals are there. Actually, by birth, they are metals, but they behave like non-metals. They look like non-metals. Those are sodium, lithium, and potassium because they are soft in nature. They are soft in nature. Even you can cut with a knife. Those metals are such type of metals. They are so soft that, like your cheese, a butter, how you are going to cut? It's like that. Cutting the butter. Take one iron rod. Cut like a knife. Can you cut with a knife? No, we can't cut with a knife. We need a welding machine, drilling machine. Am I right to cut that? Isn't it? It's so hard. You have to apply maximum pressure so that it will get cutted. It means you have to apply maximum pressure. Even a seesaw blade or something, you have to apply maximum pressure to cut it. Usually metals are so hard. But these metals, who are those? Sodium, potassium, and lithium. These are the metals which are so soft that even you people can cut with a knife. Clear? This could be a multiple choice question. Or one mark carrying question. Name the metal which can cut with a knife. Name the metal which can cut with a knife. Which is the metal we can cut with a knife? They may give you the choose the options. So you have to select which is the correct given answer. But as we know that these are the three metals as per your given textbook content. These are the three metals, sodium, lithium, and potassium. Let they give any of these three options. You can tick which is the correct among the given options. Now coming back to non-metals. Non-metals are so soft. Example, you can take except diamond. Non-metals all are soft. But diamond actually it is a non-metal. Diamond is hard. I hope you have seen, right? Diamond, isn't it? Yeah. If you hold the diamond, it's hard in nature. It is hard, but actually it is non-metal. But still, it is giving the property or it behaves like a metal. So diamond, it is a form of a carbon, which is the hardest natural substance. Which is the hardest natural substance? Naturally, it is hard. That is diamond. But actually, diamond is non-metal. But it is behaving like a metal. Potassium, sodium, lithium are metals, but they behave like non-metals. So this is the hidden property. This is the hidden property. Actually, they are something, but they behave like some other thing. It's something like that. Follow the concept? Now come back to the state. Usually, metals exist in solid state. Metals hard, as just now I told you, hard means what? It's nothing but solid state. Hard is nothing but solid state. So metals exist in solid state except mercury. You cannot hold mercury in your hand. You cannot hold mercury on your hand. Understood? Yeah, have you seen a thermometer? In the thermometer, some reading will go up and down. What it is? It is mercury. You understood my point? So except mercury. Mercury, it is not in a solid state. Now come back to non-metals. Usually non-metals exist in solid as well as in gaseous state. In both the states they are available. But except bromine. Except bromine. Actually bromine in it's a bromine is what? In which state it is? Solid, liquid or gaseous state? Bromine. As I told you, metals exist in solid and gaseous state. Except bromine I said. If it was solid state, then why I should tell here word except? If it was gaseous state, then why I should write here except? Simple word. Common sense should be applied. I'm using the word except, right? Except means, yeah. In the comment, please comment me in which state bromine is. Let me see. You have to tell, sir, bromine is in dash state. Tell me what is the dash state. Okay, let me see who all are going to answer this question. Anyhow, come back to the next nature, that is malleability. Yeah, is this clear? Yeah, malleability. What do you mean by malleable? Metals can be beaten into thin sheets. Metals can be beaten into thin sheets. You can reform. You can change them into thin sheets. Please remember, this is one of the important property. Metals can be formed into thin sheets. And non-metals, you know very well, they are non-malleable. They are non-malleable. It means it is just opposite to that. Means we cannot form into thin sheets. That is non-metals. Clear? Metals can be beaten into thin sheets. Gold and silver are the most malleable metals. As you can see, if you are going to melt the gold, any kind of ornaments you can make. Thin ornaments. You may have seen your jewelries, rings, chain, dollars. Have you seen? Yeah, that is called as thin sheets. We can change the metals into thin sheets. That is the meaning of that. Whatever the nature you want, you can convert into that nature. If you are going to change into thin sheets, that property is called as malleability. That property we call it as malleability. Similarly, ductility, it is opposite to that. Metals can be drawn into thin wires. If you are going to change into sheets, malleability. Wire, ductility. Don't get confused between these two words. Any metals can be changed into thin sheets, are malleable. Understood? And ductility is thin wires. Sir, but still I will get confusion, sir, in the exam. Please give me some code, sir. Yeah, I'll give one logic. देखो बेटा कोई सी भी चीज मैली होगी मैली मीन्स डर्टी मैली कहता क्या बेटा डर्टी तो क्या करती बेटा हासिर डालने को बैठती मैट डालने को बैठती मैट क्या एक थिन शीट हो ಗಂಧ नहीं होना बोल को ಹಾಸಿರ್ डालने बैठती बेटा that is the meaning ಕೊಳೆ ಆಗ್ಬಾರ್ದು ಬಟ್ಟೆ ಅದಕ್ಕೇನ್ ಮಾಡ್ತೀವಿ ಚಾಪೆ ಹಾಕೊಂಡು ಕೂತ್ಕೊಂತೀವಿ ಚಾಪೆ ಏನು ಶೀಟ್ कई को क्या वास्ते बेटा थिन शीट डाले बैठ रहे शीट कई बिछाले बैठ रहे अपने कपड़े गंदे नहीं होना मैले नहीं होना इन हिंदी वी कॉल्ड एज मैले डर्टी हाँ सिंपल कॉमन सेंस मैला शीट्स मैला नहीं होना बोले तो शीट डाले बैठ सिंपल ठीक है बेटा ductility you know very well ductility is nothing but it is opposite to that just now I said you thin wires understood thin sheets and thin wires no confusion and non-metals are non-ductile simple now you know very well that metals are good conductors of heat and electricity my dear students most of the give reason question this topic has been used this concept has used in give reasons questions. Metals are good conductors of heat and electricity such as silver and copper. They are the best conductors of heat. Very important. Which are the best conductors of heat? Silver and copper. Lead and mercury are poor conductor of heat. Actually, they are also metals, but they are not allowing so much current to flow. If you want limited current to flow in a wire, then we use lead and mercury. Clear? So that it is going to allow a very less amount of current. Understood? Good conductor of heat. Understood? But similarly, silver and copper, they are the best conductor of heat. It means that if you want to transfer the current for a longer distance and without wastage of current, then we use silver and copper. If you use silver and copper, you will get less wastage in the supply of current. You may have seen Olicap. So many advertisements will come, right? You have seen no in TVs any wire advertisement Polycap like the डाला गया तो wire जिंगा डाला something समझ में बेटा we have to use this wire no shocks no electric shock will come if you are going to use polycap wires kind of thing have you noted what do you mean by that example you go to a electric shop you ask him sir give me a 2 meters of wire he will give you a wire he will tell that the 1 meter wire cost is 15 rupees example he will tell that I have another quality of wire that cost is 45 rupees. What is the meaning of that? The meaning is if he is charging 45 rupees, here if he is charging 15 rupees, it's nothing but it is based on the material which is used inside the wire. Don't go upon the outer insulation. Outer wire is insulation. Inside we have a wire. That wire sometimes it is made up of copper, sometimes it is made up of silver, sometimes it is made up of a lead. Any such type of things can be made. If it is made up of a silver, then it may cost you 45 rupees. If it is made up of a copper, it may cost you 15 rupees. Example I am telling. Silver is costly. Silver is costly compared to copper. But if you are supplying here current, example in this wire, if I am supplying the current by using a silver wire, okay, example 100% current I have started supplying from here. 100% current if I have started supplying from this side, then here around 98% current will reach. It means only 2% loss will be there. If you are using silver wire, example. So how this loss takes place? See, whenever the current flows, the wire gets heated up. The wire get heated up. You understood my point? It means that the waste is nothing but it is converting in the form of heat and it is becoming waste. समझ में आया बेटा वायर क्या हो रहा है गर्म हो रहा है वायर क्या हो रहा है गर्म हो रहा है गर्म होने का मतलब क्या वो वेस्ट हो रहा है जितना वेस्ट हुआ है करंट इधर से उधर जाते वक्त वो हीट के फॉर्म में कन्वर्ट हो रहा है वो हीट हमारे को जरूरी नहीं है बस करंट जरूरी है वी वांट ओनली करंट वी डोंट वांट हीट विल गेट evaporated we are not going to use that heat clear sir good so 100% current if you supply we will reach 98%. Similarly in case if you are using copper wire 100% of current if you are sending assume you will be reaching 80% of current 20% will be loss. Example I am telling. It means I am showing you the difference. So that a high quality of wire if you are using is nothing but you are using best conductors of heat, understood metals. Whenever you are using the best conductors of heat, so that whenever you ask any wire, you should tell which type of wire is inside it, whether it is silver or copper or aluminum kind of thing. You need to confirm that first. All are the good conductors of heat. But the best among everyone is silver. Followed the concept? Sure? Yeah, very good children. Now my dear students, I hope you have understood. Now coming back to non-metals. Non-metals are poor conductor of heat. They are not allowing the current to flow through it except graphite. Actually graphite is a non-metal but still it is allowing the current to flow. Graphite is a non-metal but still it is allowing the current to flow. Any doubts? Concepts are clear? Now density. Generally metals have high density and high melting point. If you want to melt them so easily they won't get melted. For an example you take iron. If you want to melt iron you want around 1500 degrees Celsius temperature. How much degree? 1500 degrees Celsius temperature. In that scenario it's going to melt. We know very well that just we have seen only 100 degrees Celsius temperature only in our daily life. That is boiling point of water. Boiling point of water is 100 degrees Celsius. We have just seen only that particular temperature. Then here is 1500 degrees Celsius. Then imagine how much that temperature could be. It's not so easiest temperature. Then we are using some different furnace like blast furnace. We are using different furnaces. Understood? Yeah, girls. We are using different furnaces to melt such type of metals. So they have high melting point, due to which even if you pass the current through metals, they are not going to melt. Why they are not going to melt? Why they are not going to change their state so easily? Because they have high melting point. Very, very, very important question this. Example, in the filament of electric bulb, we use tungsten. In electricity chapter, you have already studied this topic, tungsten, right? Tungsten, it is a metal which is used in the filament of electric bulbs. In electric bulbs, in the filament, we use tungsten. Why do we use tungsten? Because it has high melting point. So easily with certain temperature, it's not going to melt. Very high temperature when it attains, then only it is going to melt. So soon it's not going to melt. So only we use metals. So only we use metals. So metals generally they have high density and high temperature and high melting point. So except sodium and potassium. As you know very well that just now we have discussed, sodium and potassium are so soft that even you can cut with a knife. It means that with a very, very, very low melting temperature also they will melt. Just you take sodium, keep on your palm, it will melt. It will get evaporate so easily. Am I right? Yes, sir. Sodium it will evaporate. Potassium it will evaporate. It is very highly reactive metal. Very shortly, very soon it's going to react. Understood? So here, non-metals they have low density and low melting point. Non-metals are low density and low melting point. Now metals are sonorous. Sonorous means they produce sound. What do you mean by sonorous? Metals they produce sound. That is called as sonorous. Example, take spoon, drop it, you'll get the sound. Take the bell. Have you seen your school bell? Yes. If you ring, the sound can reach for maximum distance because they have sonorous property. Even this question could be a give reason question. In the bells, we use metals. Why? Why metals are used to manufacture bells? Which property of the metal helps to make the sound? Sonorous. Sonorous is that type of a property. When it strikes with some other substance, it makes the sound. When it touches some other surface, it makes the sound. So it metals produce sound on striking any hard surface. Whenever it touches any hard surface, it makes sound. Example, you take a plastic jug, drop it. You may not get that much sound. Take a spoon or your vessel, drop it. Understood? Spoon or plate. Drop it. You'll get the sound, right? Yes. Because of sonorous property. Sonorous is nothing but sound. Lustrous is nothing but shine. Lustrous means shining. Sonorous means sound. Malleable, thin sheets. Ductile, thin ones. Concepts are clear? Very good. And oxides. Metallic oxides are basic in nature. Metallic oxides are basic in nature. About this, we are going to study in detail in this chapter. Don't worry. What is the meaning of this and how they are going to form, how they are going to react, we'll understand. Anyhow, metallic oxides are basic in nature and non-metallic oxides are acidic in nature. Non-metallic oxides are acidic in nature. I hope you have understood the properties of metals and non-metals. And also sometimes, my dear students, we can expect a question in this form also. Write the differences between metals and non-metals with respect to physical properties. Write the difference between metals and non-metals with respect to their physical properties. Then you cannot write metals and non-metals generally whatever you want. First, you have to see they are asking with respect to physical properties. Means only physical properties you have to write. Nothing else. Okay. Now we are going to discuss about chemical properties of metals. Chemical properties of metals. Children, now we are going to study about chemical properties of metals. The first option is reaction with air. So how the metals behave when they react with air. And second thing we are going to study how the metals will behave when they react with water. This is second case. And third case, how the metals will react when they react with dilute acids. Clear? And similarly, how the metals will react when they react with the solutions of other metal salts. Clear? And how the metals react with non-metals. That we are going to study. So these are the different reactions we are going to study here. Any doubts? Concepts are clear? Please remember, and if it is possible, make a note of these points. It is very important for you all guys. How the metals react with air, how the metals react with second case is water, and similarly with dilute acids, and the fourth case is with the solutions of other metal salts or metallic salts. Okay, it's very interesting, children. Okay, now metals react with air. Whenever the metals combine with oxygen, they form metallic oxide or metal oxide. What do you mean by metal oxide? Just what I told you in the next session about oxides. Metal oxides word came right in the earlier case. Here, metallic oxides are basic in nature. We said no. Now we are discussing what is this metallic oxides and how these metallic oxides are formed. Okay. Whenever the metal react with or combine, react is nothing but combine. Reacting, combining, all are same. Okay. When metals combine with oxygen, they form metal oxide. In that metal is there and also oxide is also there. Example, you take any metal plus oxygen. This is the standard form. Children, this is the standard form. So what is the standard form? Metal plus oxygen gives metal oxide. Any metal you take. When it react with oxygen, that metal oxide. Example, copper plus oxygen, copper oxide. Copper is metal. Oxygen, it give copper oxide. Aluminum plus oxygen, aluminum oxide. Magnesium plus oxygen, magnesium oxide. My dear students, and remember, wherever I have given the color, why I have given the color, because in examination, the chances are there for few metallic oxides, they will ask you the color. Wherever the chances are there, I have mentioned their colors. Wherever chances of asking the color, not for all they will ask the colors. Few topics are there, few metal oxides or any substances are there, products are there, where they will ask you the colors. Only for such type of questions I am mentioning here the color. So remember this point. So copper, when it reacts with oxygen, it gives copper oxide. See here, Cu plus O2 gives CuO. This is the reaction. Now it is not balanced. Why it is not balanced? Because here we have 2 moles of oxygen. But here we have 1 mole of oxygen. Now I want to make it 2. So what I have done, I have added 2 here. Now what it become? It becomes 2O. And also it has changed Cu. Now it becomes 2Cu. But here is 1 Cu. So I am adding 2 here. Now it is balanced. 2 Cu plus 2 O2 gives 2 Cu plus 2 O. That is 2 plus 2, 4, 2 plus 2, 4. Now the reaction is balanced. In case if any of you have difficulty or how to balance the chemical reaction, comment below. I'll make a separate video only for that, how to balance the chemical reactions. Okay? Good. Fine. Come back to the concept here. Now, as you can see, aluminium plus oxygen, it gives aluminum oxide, Al2O3. This is the standard formula. Magnesium plus oxygen, Mg plus O2 gives MgO. This is a standard formula. Now, different metals show different reactivities towards oxygen. Different metals show different reactivity, which means some metals react very faster, some metals react slower. Understood? Concept is clear. For an example, in a class, we have got 10 students. We know very well that all the 10 students will not perform in same manner. Someone may take 10 out of 10. Someone may take 10 out, another 10 out of 10. Someone may take 7 out of 10. Someone may take 3 out of 10. This shows that they are weak and these are strong. It means they are very highly reactive. These are least reactive. Some metals react very faster and some metals react a bit slower compared to the previous one. That is what we say that metals show different reactivities whenever they are reacting with oxygen. Understood? The reactivity changes. Clear? And similarly, come back to the concept. Let me understand what exactly the meaning of this here in a small paragraph. As you can see, as I stated here, metals show different reactivities. I have stated here, different metals show different reactivities towards oxygen. How? Let me see. Sodium and potassium react so vigorously. Vigorously means very faster, very fast. Sodium and potassium react so vigorously that they catch fire if kept in open so that they are immersed in kerosene. Just you take one sodium example, just open sodium, you keep it here. See here and see here. Sodium is not there. It reacts with, see, in our atmosphere we have oxygen. Just to open the sodium, keep sodium here, turn your face here and turn here. Sodium is not there. It reacts so faster. That is called as vigorously, fastly, faster. It reacts with oxygen so vigorously, and even that they catch fire if kept in open. Simply if we keep open, sometimes it will catch fire. It will catch fire. So to prevent that, we are going to keep the sodium or potassium in kerosene. In kerosene, it's not going to react. In kerosene, it's not going to react. This will be a give reason question. Why sodium is preserved in kerosene? Give reason. Could be a question. Understood? Because it reacts vigorously with air or oxygen. Whenever, one more thing. Whenever you read a word air, whenever I use the word air, air is nothing but here oxygen. Don't get confused. When I say sodium react with air, is nothing but it is reacting with oxygen. That is the meaning. That's the meaning. Clear? Yeah, air means oxygen. So sodium and potassium react so vigorously that they catch fire even we kept it open. So we are going to store that or keep immersed in kerosene. Surfaces of magnesium, aluminium, zinc, lead, Pp means lead, are covered with a thin layer of oxide. We are going to cover them with a thin layer of oxide. We are not going to keep them just open. We are going to cover them and we are going to keep. Example, take any food item. Can you keep the food item as it is? No. We cover it in a plastic bag or something. We roll with an aluminum foil kind of thing. Example, I'm telling. We cover them and we keep. Example, you take one roll, chicken roll. If we keep it as it is, what happens? Imagine. The roll, it become cold. First it is hot. In a hot state, it is consumable. We can have it. Once if that hotness goes, understood. So it become rancid. It is not in the state to eat. Am I right? Yeah, similarly, even here also, magnesium, aluminum, zinc, and lead, we are going to cover with a thin layer of oxide. Why is this? Because to prevent them from further oxidation, they should not become rancid. No further oxidation should take place. That is rancidity. If you are going to keep them open, further oxidation will take place and they become rancid. They are not in a state to consume. They are not in a state to use. So what we do? We are using a layer of oxide. Metal oxide we are going to paste on it and we are going to keep inside it so that no further oxidation will take place. Even this is your give reason question. Even this could be your give reason question. Am I right? Why? So magnesium, aluminum, zinc or lead are covered with a thin layer of oxide. Give reason. In case if we are not going to cover them with a thin layer of oxide, further oxidation will take place. To prevent it, we are covering with a layer of oxide. Concept is clear? Similarly, Fe means iron. Iron does not burn on heating. Just you hit any iron rod, it's not going to burn. But iron fillings burn vigorously. Small iron fillings have you seen in the magnetic effect, in the magnetic effect of electric chapter we have seen when iron fillings, small pieces are there. No? You hit them. they burn. They will get heated up. But iron will not get heated up. Means iron does not burn. Whenever you are going to heat the iron, it's not going to burn. But iron fillings will burn. Copper does not burn, but is coated with black copper oxide. Copper does not burn when it is coated with black copper oxide. When it is coated with a black copper oxide, copper does not burn. If it is not coated, it's going to burn. Concepts are clear? Good. Then AU means aurum, that is gold. AU is called as gold. Gold and AG. AG means silver. Gold and silver does not react with oxygen. This is a special character. This is a special property. Almost all we have seen, so many things are going to react with air or oxygen. But here, gold and silver, it's not going to react with oxygen. This also can be a give reason question. Example, every day we are using a gold jewelry. Women's we use, right? Even the men's also will use a gold chain or silver chain kind of thing. We are using it. Am I right? See, it's not going to react with air. When I'm wearing, air is not coming to my body. It's not hitting my body. Hitting or not? Yes, it doesn't hit my gold chain or silver chain. It's going to hit. Hit means it is reacting. Even though it is reacting, do you think that it gets corroded? Any rusting will take place here? No. Because they does not react with oxygen. That's the reason. Since they does not react with oxygen, gold and silver does not react with oxygen, so only those are very precious metals and it is used in the manufacturing of jewelries. Understood? We are not using copper. We are not using aluminum in the jewelries. To manufacture the jewelry, we are not using that because they react with oxygen. Since they does not react with oxygen, so only we are using them in the jewelries. So only they are so costlier compared to other metals. Understood? Because of the reaction. My dear students, very important question, that is amphoteric oxides. Very important question. That's nothing but amphoteric oxides. Let's see. What are amphoteric oxides? Let me ask you this question. What are amphoteric oxides? Give example. Sometimes an indirect question also can be formed on this topic. Indirect question also you can expect on this topic. Now, what are amphoteric oxides? Metal oxides. It's not metal ice. That is metal oxides. Okay. Metal oxides which react with both acid as well as bases. Some metal oxides are there. They react with not only acids. They react with acid as well as bases to form salt and water. To form salt and water. So they are, we call them as amphoteric oxides. Metal oxides which react with both acid and base are known as amphoteric oxides. Have you heard a word in biology, amphibians? Animals? Amphibians. What do you mean by amphibians? The animals which can live both on land and water are known as amphibians. Similarly here, metals and non-metals. Land and water, metals and non-metals. Example, amphibians, amphoteric oxides. See the words amphibians, amphoteric oxides. Clear? They live both in land and water. Here, they react with both acid and base. What is the product formed in amphoteric oxides? Salt and water. Example, aluminum oxide Al2O3 plus hydrochloric acid. It gives aluminum chloride plus water. Aluminum chloride plus water. Understood? Similarly, here we have aluminum oxide. What it is? Yeah, Al2O3. Aluminum oxide plus NaOH. What is NaOH? Sodium hydroxide. It's a base. Aluminum oxide is a metal oxide. Okay. It's reacting with base NaOH. Here aluminum oxide is what? Metal oxide. Reacting with acid. HCl is acid. First example is metal oxide react with acid. First reaction. Second reaction is metal oxide react with base. But still we are getting aluminum chloride. What it is? Salt. Sodium aluminum oxide, that is called as sodium aluminate. Very, very, very important, children. Please don't forget this word. Don't forget this word. Forget everything, but don't forget this one thing. This word. NaAlO2. Sodium aluminate. That's the word is sodium aluminate. What happens when sodium oxide or metal oxide react with a base, or aluminum oxide when it react with sodium hydroxide? Sodium hydroxide is a base. It gives sodium aluminate. NaAlO2. While balancing, we got this 2 after balancing. Plus water. On the whole, we have seen that whenever a metal oxide reacts with acid, it gives salt and water. Whenever a metal oxide reacts with base, it gives again salt and water. No gas is liberated here. No hydrogen gas. No carbon dioxide gas. No gas. Only water. It's nothing but water. Clear? Yes, students. Now we are going to continue with the next reaction. Now we have studied how the metals react with oxygen, that is air. Am I right? This is what we have studied, no man. Reaction with air. How the metals react with air we have studied. Now we are going to study how the metals react with water. Let's continue. Children, it's very important. So this is a standard formula. Which is the standard formula here? This one. When metal react with water, it gives metal oxide plus hydrogen gas. It's a standard formula. When metal react with water, please, wherever I am telling a standard formula, keep a note so that it will be easy for you to make any sentence. When metals react with water, it gives metal oxide plus hydrogen gas. Hydrogen is nothing but it's a gas. Hydrogen is in a gaseous state. So hydrogen gas is liberated. Similarly, after this metal oxide we got no. देखो बेटा, मेटल वाटर के साथ में रिएक्ट होने के बाद मेटल ऑक्साइड मिला. अब ये मेटल ऑक्साइड को, this metal oxide, now again you react with water, it gives metal hydroxide. See the beauty. See the beauty. Metal react with water, metal oxide. Again same metal oxide, the product what you have got, again you do further reaction. With whom? With same water. What we are getting? Metal hydroxide we are getting. Metal hydroxide. Okay. Example, you take any metal, see, react with water, sodium, potassium or calcium. Any of these three you take. Any of these three you take. Which one? These three. Can you see this? Yeah, the color is dim. Let me change the color. Even this is also dim. Okay, anyhow. Guys, observe it. Take this. Okay. React with cold water, that is sodium, potassium, calcium. They react with steam. They react with steam. Who? Aluminum, iron, zinc. No reaction with water. Which one? Which are the metals that does not react? Which are the metals that does not react with water? Lead, copper, gold, silver. Which are the metals react with water? React with hot water. That is H2O is water. That is magnesium. React with hot water, magnesium. Calcium and magnesium float as bubbles of hydrogen stick on their surface. Children, these are the key points you have to remember. Which are the key points you have to remember? When the metals react with water, which are the metals react with cold water? Which are the metals react with cold water? Sodium, potassium, calcium. You should not forget these names. Sodium, potassium and calcium react with cold water. Which react with hot water? Magnesium. React with cold water? Sodium, potassium, calcium. React with hot water? Magnesium. React with steam? Aluminum, iron, zinc. They react with steam. No reaction with water. They does not react with water. Lead, copper, gold, silver. And calcium and magnesium, they float. They float on the water. They does not dissolve. You put calcium or magnesium on the water, they float on the water. Float का मतलब क्या बेटा? Ship. Have you seen the ship will float, right? It doesn't go inside the water. It's going to float on the surface of the water. Why it's going to float on the surface of the water? Because the bubbles of hydrogen stick to their surface. That doesn't allow these metals to go inside the water. So it's going to float on the surface of the water. This will be a give reason question. This could be a give reason question. Calcium and magnesium will float on the water. Why? Because the bubbles of hydrogen stick to the surface. Understood? So that they help to float on the water. Concept is clear? Mercury react with hot water. Mercury react with, mercury no man, magnesium that one. Huh? Magnesium. React with hot water, magnesium. Children, to understand this, I'll give one logic. Sir, what all you have given, how to remember these all examples? Am I right? For that, we have to understand the reactivity series. What we have to remember? Okay. Now, for some time, I'm just quitting this part. I'm coming to another topic, that is reactivity series. Again, I will come back to that. Can you see a reactivity series? Potassium, sodium, calcium, magnesium, aluminum, zinc, iron, lead, hydrogen, copper, mercury, Hg is mercury, silver and gold. Sir, how to remember this? I'll give a small example. Logic. Ka. What is K? Ka. Na. Ka. Na. Khale ko. In Hindi, I'm giving the logic. Ka. Na. Khale ko. Manje. MG. Ka. Na. Khale ko. Manje. का ना खाले को म्हणजे आलू लाना. क्या लाना? आलू. का ना खाले को म्हणजे आलू लाना. जिद कर्या तो जिद कर्या तो लोहा मीन्स आयरन. पकड़ को पीबी. घर में हाउस घुसको. घर में घुसको कुत्ते को मारे जैसा मार. सीओ कॉपर. हाउ जी हिच जी. आओ जी ये जी. आओ जी मार को दिखाओ जी. लास्ट में आओ कर को बोल को डकार देखो जाओ जी. खाना खाले को म्हणजे आलू लाना. जिद कर्या तो लोहा पकड़ को घर में घुस को कुत्ते को मारे जैसा मार. हाउ जी आओ जी. लास्ट में आओ कर को बोल को डकार देखो जाओ जी. दिस इज रिएक्टिविटी सीरीज. Clear? I hope you have understood this. Yes, very good. Now let me come back to this concept. How to remember this? Which react with hot water, which react with cold water, which react with steam, which does not react, all the stuff. Let me see here. As I gave you the example just now, का ना खाले को म्हणजे आलू लाना. जिद कर्या तो लोहा पकड़ को घर में घुस को कुत्ते मारे जैसा मारतो. हाउ जी आओ बोल को डकार देखो जाओ जी. Yeah, can you see the first three? Children, interesting. Can you see this first three? What is this first three? These all first three are react with cold water. Simple. The first three among this in the reactivity series, potassium, sodium and calcium, they react with cold water. Next, coming back to the next topic, that is magnesium. Now magnesium react with hot water. First is cold water. The first three react with cold water, and the fourth one, that is magnesium, react with, magnesium reacts with hot water. Next, what is left out? Can you see the next three? Similar order. See the interesting. The next three, can you see in the same order? First three and next three. Next three, aluminum, zinc and iron. Now these react with steam. These three will react with steam. Am I right? Am I right? Very good. Now hydrogen is in the center because he is in the house. We don't touch him. His house, no. House will react? No, house will not react. So keep it alone. Next, what is coming back to the picture? Similarly, can you see the next one? After that, what is left out here? PB. What is left out? Copper. What is left out? Copper. Can you see here? Lead, copper, gold, silver. This all does not react with water. Please forgive mercury. Mercury you can't touch only, you can't hold only. Understood. Forget about it. Any doubts still here? Interesting? If the concept is clear, sodium, potassium, and calcium they react with cold water. Magnesium react with hot water. Aluminium, zinc, iron they react with steam. One more thing, children. Whenever I use a word steam, is nothing but the formula is H2O only. Water is also H2O. Steam is also H2O. Don't get confused. Understood? Steam formula is also H2O. Water formula is also H2O. Similarly, air formula is oxygen. Air symbol is oxygen. Even if I tell oxygen is also O2 only. Air is also O2 only. Air and oxygen both are O2. Steam and water both are H2O. Don't get confused between these words. I hope the concept is clear for you all guys. Yeah. Now let me see the reactions here. Now let me see their reactions. Example. When sodium react with water. Sodium will react with water? Yes, of course. It react with water. It gives sodium hydroxide and hydrogen gas is liberated. Along with, see, everywhere we get the heat. It's natural. It's nothing is there to comment over there. Understood? Can you see here? Sodium reacts with water. When sodium reacts with water, it gives sodium hydroxide. When metal react with water, it gives metal hydroxide. When metal react with water, it's giving metal hydroxide. Na is a metal, OH is hydroxide. That is metal hydroxide. Plus hydrogen gas is liberated. Similarly, calcium react with metal. It gives calcium hydroxide. So this is the standard formula. What is the standard formula? When a metal react with water, it gives metal hydroxide. And it gives hydrogen gas. Here you can expect one more question. Name the gas liberated when metal react with water. Many number of times this question is asked in the exam. Multiple times this question is asked. When metal react with water, which gas is liberated? Hydrogen gas. Don't get confused. Understood? Metal react with water. Name the product form. Metal react with water. Product. Metal hydroxide. OH. OH. Wherever we find a word OH, that is hydroxide. You will get only H, that is hydrogen. OH, hydroxide. H is acid. OH is base. Clear? Whenever we see a word OH, that is hydroxide. Clear? Hydroxide is nothing but base. Hydrogen is nothing but acid. H is acid. OH is base. Okay, calcium react with water, it gives calcium hydroxide plus hydrogen gas is liberated. This topic we have discussed in displacement reaction in chemical reaction and equation chapter. Quick climb and slake line. Okay. Next, magnesium react with water, it gives magnesium hydroxide. Aluminium react with water, it gives aluminium oxide. Here, aluminium oxide. Aluminium react with water, it gives aluminium oxide plus hydrogen gas is liberated. Iron react with water, it gives iron oxide plus hydrogen gas is liberated. Can you see the top three and the bottom two? In this top 3, we are getting metal hydroxide. In the next 2, we are getting metal oxide. Both we are getting. In the next 2, we are getting product metal oxide plus hydrogen. In the first 3, metal hydroxide. In the next 2, metal oxide. Don't get confused. Understood? Here, you can expect a multiple choice question. What it is? When aluminum react with water, it forms dash metal oxide, metal hydroxide. Both option A and B are none of this. Like this, they will ask you. When aluminum react with water, it give metal oxide or metal hydroxide. Yeah. I hope you have understood between these both the examples. I hope you have understood with these both the examples. Yes or no? Yeah. But here, one interesting concept is there. You know what is that interesting concept? I said sodium react with water. Am I right? Yes. It gives sodium hydroxide. Hydrogen gas liberated. Copper react with water. Magnesium react with water. Here, is it aluminum is reacting water or steam here? H3O, H2O. Formula is water. Same H2O. Formula is steam also. Steam का भी formula क्या? H2O. Water का formula भी H2O. In question they will ask you, when aluminum react with steam, when iron react with steam. Understood? Understood? Children, kindly make one important note here. Just make one note. It's very important for examination point of view. Let me to brief this concept here for you guys. It's very important. I want you have to make a note of these points. So what is that is the first 3 and the next 2. So here sodium react with water. Sodium react with H2O. It gives sodium hydroxide plus hydrogen. Gas is liberated. Okay. And one more thing will come here. After the sodium, potassium. Again, potassium reacts with water. It gives potassium hydroxide plus hydrogen gas is liberated and heat is formed. This first, and let me say this is option 2. This both, which reactions? Sodium react with water or potassium react with water. My dear students, here we are getting this hydrogen gas. This hydrogen gas will catch fire. This hydrogen gas has that ability. It has got that much strength that it can catch a fire. Remember this point. Remember this point. We are getting hydrogen gas. Here also we are getting hydrogen gas. Where? In calcium also. Can you see this? Option 2. Can you see this option 2? Yes, sir. Calcium react with water. It is getting calcium hydroxide. Here also we are getting hydrogen gas. But this hydrogen gas will not catch fire. Please remember this important note. Remember this important note. Sodium react with water, we are getting hydrogen gas. Potassium reacting water, potassium is reacting with water, we are getting hydrogen gas. This hydrogen gas will catch fire. But when calcium react with water, we are getting calcium hydroxide and hydrogen gas. But this hydrogen gas will not catch fire. So this could be your give reason question. Understood? This can be your give reason question. Please make a note. The question here. Why? Make a note. One important question here. Why? When calcium reacts with water. Why? When calcium reacts with water, it does not catch fire. Sorry, when calcium reacts with water, comma, when calcium reacts with water, comma, the hydrogen gas is liberated. The hydrogen gas is liberated. It does not catch fire. It does not catch fire. Whereas sodium and potassium, whereas sodium and potassium reacts with water, reacts with water, comma, the hydrogen gas is liberated, hydrogen gas is liberated, it catches fire. Hydrogen gas is liberated, it catches fire. Question mark. Okay. See here, the meaning is from sodium we are getting hydrogen gas. From potassium also we are getting hydrogen gas. This hydrogen gas will catch fire. But when calcium we are getting hydrogen gas, this hydrogen gas will not catch fire. Why? Here also hydrogen gas, there also hydrogen gas. Here it is catching fire, जल्दी अंगार लग जाती है उसमें. लेकिन इसके अंदर जो हाइड्रोजन आ रहा वो जल्दी अंगार उसमें नहीं लगती. क्यों? Why? What is the reason? Take down the answer. Because 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 yes, answer. Because heat liberated heat liberated is not sufficient. Heat liberated is not sufficient to catch fire. Because heat liberated is not sufficient to catch fire. वो हीट के अंदर इतना स्ट्रेंथ नहीं है कि वो फायर बन सके. In terms of calcium. Understood? Is the concept is clear? Good. So my dear students, as we have noted here that when a metal react with water, we are getting metal hydroxide, calcium react with water, calcium hydroxide, magnesium react with water, we are getting magnesium hydroxide, and the aluminum is reacting with water or steam. Here aluminum is reacting with water or steam. Sure. Yes. Confident? Yes. You are absolutely right. Please make a note. Make a note. One important point here. One general formula. When metal react with, please make a note. One general formula so that you will not get confused. Even in exam also they will give the word like water or steam. They will give the word. Okay, don't get confused. When when metal reacts with when metal reacts with oxygen, it gave metal oxide. This we have already discussed. Plus hydrogen gas is liberated. Similarly, second case we have seen when metal react with water, it gives metal hydroxide plus hydrogen gas is liberated along with heat. Similarly, when metal react with steam, it gives metal oxide. It gives metal oxide. समझे बेटा? कब खाली ऑक्साइड आ रहा, कब हाइड्रोक्साइड आ रहा? Hey, you can see here, no man. I told you, no, H2O, H2O. Here also H2O. Here we are getting hydroxide. Here we are getting only oxide. Understood? When metal react with water, we are getting metal hydroxide. When metal react with steam, it gives metal oxide. The first three are the examples of when metal react with water. The next two are the examples of when metal react with steam. Since they react with steam, we are getting hydroxide. Sorry, we are getting oxide. Since it is reacting with water, we are getting hydroxide. Understood? Understood? Yeah. Now, I think you have studied one chapter, displacement reaction. Remember? Yeah, make a note of this example. Please make a note of this example. This could be your examination question. When metal A, make a note. When metal A, react with a metal solution of B, when metal A reacts with a metal solution of B, it gives metal solution of A plus metal B. Metal B. When metal A react with metal solution of B, it gives metal solution of A plus metal B. For an example, metal A is iron. When iron react with copper sulfate, can you see this? This is metal solution of B, copper sulfate. When iron react with copper sulfate, it gives iron sulfate plus copper. So this reaction we call it as displacement reaction. This topic already we have discussed in the chapter chemical reactions and equations. Clear? Understood? When iron react with copper sulfate, it gives iron sulfate plus copper. Understood? This reaction is displacement reaction. Concept is clear? Similarly, when zinc react with H2SO4, it gives zinc sulfate plus hydrogen, sulfuric acid. When zinc react with sulfuric acid, it gives zinc sulfate. Similarly, when lead react with copper chloride, it gives lead chloride plus copper. What is this all? These all are metal A. When it reacts with metal solution of B, it gives metal solution of A plus metal B. I hope the concepts are clear about this topic. Sure? Yeah. Now, we proceed with the next topic, reaction of metals with acids. When the metal react with acids, already we know that when a metal react with dilute acid, it gives salt and hydrogen gas is liberated. Children, this is the standard formula. So where all I am telling as a general formula, you write it in note in separate one sheet after the end of this chapter separately. When metal react with dilute acid, it gives salt and hydrogen gas. But already we know that copper, silver, mercury, they do not react with dilute acids. Remember, important note. Which do not react with acids? Copper, silver, mercury. Understood? They does not react with dilute acids. But gold will react. AU, gold will react. But these will not react. Okay. Now, example. Iron react with HCl. It give ferric chloride. Fe means ferrous. Iron. React with HCl. Which acid is this? Dilute acid. It gives ferric chloride plus hydrogen gas. Magnesium react with hydrochloric acid. Magnesium chloride. MgCl2 plus hydrogen gas. Zinc react with hydrochloric acid. It gives zinc chloride plus hydrogen gas. Aluminium react with hydrochloric acid. It gives aluminium chloride. AlCl3 here. Actually, it's not AlCl2. It is AlCl3 plus hydrogen gas. Okay. Similarly, now we come to the topic which I have discussed just earlier. I gave the examples now here. Reaction of metals with solutions of other metals, other metallic salts. Remember, metal A, when it reacts with metal solution of B, it gives metal solution of A plus metal B. It means that reactive metals can displace less reactive metals from their compounds in the solution form. This is the definition of a displacement reaction. A highly reactive metal will displace a least reactive metal. Such a reaction is called as displacement reaction. Okay. And also we have discussed about reactivity series just now. Children, remember the upper one is the most reactive metal and below one is the least reactive metal. So here we have given in an order. As you can see, sometimes they will give you some metals. Sometimes they will give you some names of the metals like K, Ca, Mg, Cu, okay, Fe in an order, in an irrespective order. They will ask you to arrange them in an increasing order. Arrange them in their decreasing order. Like this also the questions can be asked for you. Increasing order and decreasing order. Can you see this? As the metal is coming from most reactive to least reactive down the series. That is decreasing order. If you go up the series, increasing order. From less to more. From more to less. More to less, decreasing order. From least to more, increasing order. And the center one is what? H. H is the center. Above H, all are more reactive metals. Below H, all are least reactive metals. Don't forget. Which are the highly reactive metals? Till Pb. Till Pb. Below H, least reactive metals. Above H, highly reactive metals. Understood? Don't get confused with this word. Understood? Good. Now, reaction of metals with non-metals. Reaction of metals with non-metals. Okay. Sometimes they will ask you one more question. Which is the highly reactive metal or most reactive metal? Example? Potassium. Which is the least reactive metal? Gold. Sometimes we also call it as platinum. Below gold, platinum will come. PT. Platinum. After gold, platinum will come. Okay. Now, reaction of metals with non-metals. Now, how metals react with non-metals and what they are going to form. So, reactivity of elements is the tendency to attain a completely filled valence shell. Reactivity of the elements is the tendency to attain completely filled valence shell. It means that, observe here. What is the meaning of this? See here. For example, children, this explanation is very important. Again, I am repeating. Very, very, very important. In everyone's life, some goal is there. In everyone's life, some goal is there. If a person reach to that goal, he's completely a satisfied person. Am I right? When you reach your goal, you're completely satisfied. Will you agree? Sure. Suppose I want 100 rupees. That is my goal. When I get 100 rupees, what I will do? Situation 1. No, I don't want you to answer here. It's just a situation 1. Actually, I want 100 rupees. I have already 100 rupees with me. Situation 1. Situation 2. Same goal. I want 100 rupees. But with me, I have 80 rupees. What I will do? Situation 2. Situation 3. I want 100 rupees. But my goal is 100 rupees. But here I have 120 rupees. What I will do? These are the 3 situations. Confirm? Followed? Understood the 3 situations? First situation, I want 100 rupees, then I have 100 rupees. Second situation, I want 100 rupees, but I have 80 rupees. Third situation, I want 100 rupees, but I have more than 100 rupees. I'll explain you what exactly is going to happen here. Okay. When I have 100 rupees with me as per my goal, either or neither, I will give or I will take. I will stay alone. My goal is 100. I have 100. Do I want to ask with someone? Please give me some money. Or do I want to give someone? No. Here the policy is simple. I don't want to give or I don't want to take. Simple. Because he is in a stable state. He is already stable in his life. Now this fellow, 80 rupees fellow, to fulfill his needs, he is taking 20 rupees from someone, borrowing. Please give me. He is asking credit with someone. He is asking 20 rupees from someone to fulfill his needs. Am I right? Now this fellow, he want 100, but he have 120. Then he is ready to give, donate. He is ready to donate extra rupees. He is ready to donate extra rupees how much he has for someone. Am I right? Situation 1, he is already stable. Situation 2, If you want to lead his life happily, he wants this fellow, he want to live happily, he should give. If he give only, he will be satisfied because 100 is a target. 100 is the target. It means I should not have excess also. I should not have deficit also, means less also. समझ में आया बेटा? जब 100 हमारा टारगेट है तो 100 से हमारे को ज्यादा भी नहीं चाहिए, कम भी नहीं चाहिए. समझे? Understood? हाँ. Now forget about situation 1. Come to situation 2 and situation 3. That is what this definition speaks. Why we are doing reactivity here? Why reaction is important? Why one metal should react with some other metal or non-metal? Why they want to react? Because to fulfill their needs. Some valence shells are there. What is there? Valence shells. So what is valence shell? I'll tell you. Children, this is very beautiful concept. Seriously, I'm telling you, very beautiful concept. See, I'll show you one atomic structure here. Okay. Let me take one atom. This is first orbit. This is second orbit, third orbit, fourth orbit. Okay, let me saw one more orbit. This is my outermost shell. This is my outermost shell. Am I right? And this one is my innermost shell. Every atom, every element has one goal in their life. What they have? Goal. समझ में बेटा? उनके पास एक गोल है. क्या गोल है? What is the goal they have? The goal is very simple. In their outermost orbit, they should have 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. When they achieve these 8 electrons in their outermost shell, then they are stable in their life, satisfied in their life. So, such type of elements in chemistry, we call them as noble gases. Such elements we call as noble gas. Noble gases are those elements. In their outermost shell, they have 8 electrons. Already they have 8 electrons in their outermost shell. So they neither donate nor accept. They are completely satisfied in their life. Clear? Clear? जब उनके outermost shell में 8 electrons आ जाती, तो न किसी से कुछ लेती, ना किसी को वो देती. So they are called as stable. They are stable gases. They are noble gases. Understood? Understood? Yes, sir. Now, when the reaction should happen, example, I want 8 electrons, but I have 6 electrons. Now, to achieve another 2 electrons, with the neighboring atom, I have to react. Have to react means you have to contact the neighboring atom. Excuse me, please give me 2 electrons if you have. You have to react with them. You have to communicate with them. Once you communicate, then this fellow, he will give 2 electrons for you. Then you will become stable in your life. Understood the concept? Understood the concept? But my dear students, even he is jealous. He is jealous. Even he is also trying to become stable. If we give 2 electrons to him, then he will become deficient, right? इसके पास कम हो जाती है ना electrons. इन्हें क्यों देना? Correct, no? You understood my point? If we give 2 electrons from him, 2 electrons he has lost. Actually, he also want 8 electrons. इन्हें भी 8 electrons को जपले को है. इन्हें भी 8 electrons को जपले का है. अब इधे इसको दे दिया तो क्या होगा? इसे भी प्रॉब्लम होगा ना. इसके पैसे क्या हो रहे? कब हो रही? इसके पॉकेट में से. Regarding this, we are going to study here how it's going to happen. Don't worry. On the whole, my intention and our goal is both should be stable. दोनों stable होना. हमना उससे मतलब है. हमना किससे मतलब है? दोनों भी क्या होना है? Stable होना है. समझ में आया बेटा? Stable का मतलब क्या? In their outermost shell, 8 electrons should be there. That is the target. चाहे इसके पास 2 रहो या 6 रहो या 10 रहो. On the whole, फाइनल में क्या होना है, 8 इलेक्ट्रॉन्स उनके आउटरमोस्ट शेल में होना है. In their outermost shell, they should have 8 electrons. Such a structure we call it as octet structure. Such a structure is called as octet structure. The elements, the atoms which has 8 electrons in their outermost orbit or outermost shell is called as octet structure. So all the noble gases, they have octet structure because they have 8 electrons in their outermost orbit. Any doubts? Concept is clear? Why they want to react, you understood? To fulfill their valency. Valency का मतलब blank shells. जो empty थे ना shells, उसको बोलते हैं valence shell. Valence का मतलब empty shells. अब इसे दो की जरूरत थी, और वो दो गैप था. Two was unfilled. To fill that, he should react. So reactivity is required. So only reactivity will occur. Okay. Now, my dear students, observe here. Atoms of metals lose electrons. देखो बेटा, ऑलरेडी हमारे पास एक प्रॉपर्टी पता है ना, वी हैव ऑलरेडी स्टडीड इन आवर 8th and 9th standard. What is that property? Metals always they like to donate the electrons. Am I right? Metals will donate the electrons. देखो बेटा, metals आपको डोनर, खाली उनको देना आता. Only they like to give. And non-metals always they like to accept. खाली उनको लेना आता. Clear? Metals they like to donate. Non-metals they like to accept. This is the property of metals and non-metals. Similarly, atoms of the metals lose electrons. Why they lose electrons? Why atoms of metals will lose electrons? Because they are donating. Since they are donating, I have 10 rupees in my pocket. If I am giving 2 rupees to someone, it means it is my loss. Since I am donating, it is my loss. The other side, he is accepting, it is his gain. It is his gain. So metals lose electrons from their valence shell to form cation or cation. Cation. जब वो डोनेट कर रही तो उनका कौन सा आयन फॉर्म होता? They form cation or cation. Now atoms of non-metals they gain electrons. Then their valence shell will become anion. तो उनका valence shell क्या हो जाता? Anion हो जाता. उन्हों दे रही तो cation, तो इन्हों ले रही that is anion. Now, my dear students, one most important question for your examination, please make a note. The question can be like this. Please make a note this question. Briefly explain the formation of sodium chloride. Briefly explain the formation of sodium chloride. Briefly explain the formation of sodium chloride with the help of dot structure. Briefly explain the formation of sodium chloride with the help of dot structure. Okay, it means they are asking you how sodium chloride is formed. How sodium chloride is formed. Yeah, observe here. My dear students, sodium is Na. The atomic number of sodium is 11. What is the atomic number of sodium? 11. Clear? And you know very well, let me say this is a sodium atom. It's a sodium element. Now here, in the first shell, it can hold, there is one condition. In every shell, how many electrons they have to keep? Remember, the condition is 2n square. The first orbit is 1 means n value 1. Second orbit 2 means n is 2. Understood? Remember this? Understood? Third orbit n is 3 means n is 3. Fourth orbit n is 4. Like this, we are going to create the orbits. समझ में आ बेटा? अब इसके बाद अंदर n की वैल्यू 1 है. The value of n is 1. So in first orbit, how many electrons we can keep? 2. N is 1. 1 square is 1. 1 into 2, 2. In first orbit, we can keep only 2 electrons. That is the capacity. In second orbit, how many electrons we can keep? N value 2. 2 square? 4. 4 2s are 8. It means we can keep 8 electrons in second orbit. 1, 2, 3, 4, 5, 6, 7, 8. Correct? In first orbit, how many? 2 electrons. In second orbit, 8 electrons. How much we want? 11 electrons. How much we want? 11 electrons. Now, how many electrons are left out? 1 electron. In first orbit, 2 electrons. Second orbit, 8 electrons. 2 plus 8, 10. Now, left out is 1 electron. In third orbit, how many electrons we can keep? 3 square. 9. 9 2 are 18. 18 electrons we can keep. अब 18 में से एक इलेक्ट्रॉन को हमें रख सकते हैं इसमें 18 इलेक्ट्रॉन्स रखने की कैपेसिटी है बेटा एक बस है उसमें 18 जने बैठ सकती है उसमें एक आदमी नहीं बिठा सकते हमें we can make him to sit right in 18 passengers can sit in that we cannot keep one passenger yes we can keep so altogether now as you can see in the outermost shell how many electrons are there one now if he has to become a stable then how many electrons are required for him 7 electrons are required अब ये फुलफिल होना तो आउटरमोस्ट शेल इसका आउटरमोस्ट शेल फुलफिल होना तो इसे कितने इलेक्ट्रॉन्स की जरूरत है 7 इलेक्ट्रॉन्स की जरूरत है नो व्हाट आई हैव रिटन कैन यू सी दिस innermost shell we have written 2 first shell we have written 2 second shell we wrote 8 third shell we wrote 1 that is what we have given here can you see this what this indicates what is this first two indicates in the first shell we have kept 2 electrons what next 8 indicates in second shell we have kept 8 electrons what third shell indicates in third shell we have kept 1 electron समझे अब इसके नजदीक में कौन था सोडियम के नजदीक में कांटेक्ट में क्लोरीन मिल अब क्लोरीन का एटॉमिक नंबर कितना क्लोरीन एटॉमिक नंबर इज 17 what the atomic number of chlorine 17 now how we are arranging the shells in chlorine in the first shell we are keeping 2 second shell capacity 8 third shell capacity in that we are keeping 7 now dear students please observe here carefully in this outermost shell how many electrons are there we are not bothered about innermost shell we are just bothered about outermost shell electrons देखो बेटा सोडियम के आउटरमोस्ट शेल में कितने हैं इलेक्ट्रॉन्स 1 क्लोरीन के आउटरमोस्ट शेल में कितने इलेक्ट्रॉन्स हैं 7 अब 1 8 बनना इजी है या 7 8 बनना इजी है विच इज इजी is 1 to become 8 is easy or 8 to become sorry 1 to become 8 is easy or 7 to become 8 is easy 7 to become 8 then ultimately what happened observe here very interesting seriously observe here now what happened now this is my sodium and this is my chlorine this is my sodium and this is my chlorine in sodium in outermost shell I have 1 electron in chlorine in outermost shell I have 7 electrons then sodium decided if I remove this one if I remove this one चला गया अब 1 इसके पास चला गया किसके पास क्लोरीन के पास 1 इलेक्ट्रॉन किसके पास चला गया क्लोरीन जब एक इलेक्ट्रॉन चला गया तो वो रिंग भी क्या हो जाता कोलैप्स हो जाती है इट विल गेट रिमूव्ड understood once if that ring get removed you understood or not didn't understood see here I'll tell you once again this is my sodium first orbit second orbit third orbit in third orbit 1 electron is there when sodium is donating this 1 electron to chlorine then what happens automatically this ring will goes out now which will become the outermost shell second ring will become outermost shell now the second ring became the outermost shell now how many electrons are left out in outermost shell 8 he's stable now chlorine he has 7 electrons no he accepted 1 electron then he became 8 now he is also stable so sodium chloride form understood when sodium donated one atom to chlorine then what happens sodium has got now 8 electrons in its outermost shell and even chlorine also has got 8 electrons in its outermost shell so that sodium donated so he got plus and chlorine he got minus. So this is how the formation of sodium chloride has formed. On the whole, ultimately, finally, what happened? The outermost shell, 8 electrons he has. Chlorine also in the outermost shell he has 8 electrons. Both have 8 electrons in their outermost shell. This is how the formation of sodium chloride has formed. My dear students, similarly, you have to learn how the magnesium chloride, explain the formation of magnesium chloride, explain the formation of uh, aluminum chloride, AlCl3. How magnesium chloride will form and how aluminum chloride will form with the help of dot structure. Even this also your examination question. Explain the formation of sodium chloride, explain the formation of magnesium chloride, and explain the formation of aluminum chloride. I hope you have understood the formations here. Good. Dear students, this is what the electron dot structure. I hope you have understood this class. Very good. Congrats. Keep it up. My dear students, yet if you are not subscribed to our YouTube channel, Shah Sir Classes, kindly do subscribe and click the like button. And also share this video with your other friends. In our next part 2, we are going to continue this chapter. Take care. All the best.